Hello everyone. Welcome to the past paper discussion. In this video, we are going to discuss 18-mark question. And yeah, in this particular series, we are at the sixth question, right? And let's get started. This question, basically, it's roll over the statistics and probability stuff. And I hope it will be a good recall for you about the concepts, right? So pay attention. Let's do every part step by step in detail, right? So a company makes doors for kitchen cupboards from two layers. The inside layer is wood and its thickness is normally distributed with mean 7 millimeter. Okay, so two layers, one is wood, it is normally distributed with mean 7 millimeter and standard deviation. Of course, the things that we want for the normal distribution. And another layer is plastic, which is the outside layer, and its thickness is normally distributed with mean and standard deviation given here, 3 millimeter and 0.16 millimeter. Now, the first question is for 5 mark, find the probability that a randomly chosen door has a total thickness of less than 9.5 millimeter. If you choose a door random from this, total thickness of this will be less than 9.5, right? Okay, so now the random variable is the total thickness, right? So let me make wood is normally distributed as this. So probability of, this is what I need to find for the A part. Probability of my X is actually wood plus P, that is wood plus plastic. This should be less than 9.5. I'm looking for this. So for wood and plastic, I know the distribution, their mean and standard deviation. But how to find it for this thickness? Let's go. Expectation, expected value, E of X and variance of X, right? So E of X is nothing but 7 plus 3. You just add wood and this 10 expected. And variance of X is variance of W plus variance of P. Here actually this is a standard deviation. How will you find variance of W? So variance of wood is just square it. Standard deviation is sigma, variance is sigma square, correct? So standard deviation is 0.3 means this is 0.3 square. For plastic case, standard deviation is 0.16, so this is just 0.16 square. And it's a very simple calculation, so I'm not going to show the calculator for you. Just solve it and you will get around 0.1156. Okay, for calculating probability for a normal distribution, I want a standard deviation. I have variance of this thickness, right? The random variable for thickness. So how will you find the standard deviation for it? So standard deviation for X is going to be square root of 0.1156. Use your calculator. That's quite simple. And you will get it around 0.34. Done. Now I have, so my X is distributed normally with mean 10 and standard deviation 0.34. And I need to solve for probability of X less than 9.5 here. It's simple. Now we can just go with the graphing calculator, right, to solve this one. So using technology, here we go. Okay, what should I do first? Go for the calculator page, menu, probability and distribution. It is distributed normally. And one more thing. So we have to use normal PDF or normal CDF. So I am solving for X less than 9.5. So go for CDF. Okay. So X less than 9.5. So keep this in mind. X less than 9.5. So what is the lower bound? Lower bound is like X less than 9.5 till infinity. So it's already there. Or you can put some bigger number, minus, and put a lot of 9. And then upper bound. Upper bound is going to be, mostly we will give 9.5. But 9.5 is not included. So give a very close number to 9.5, which is 9.4999. Like this. That's it. And what is mu means in this calculated mean? Sigma is standard deviation. We know that. So mu is 10. We are solving for wood plus plastic total thickness. So 10 And this we found it just now 0.34. Hence we have given all the stuff. We got this. That's the probability 0.070701. And switching to the solution page, here we go. Right, that is the required probability. Probability that a randomly selected door have a total thickness less than 9.5 is this. 0.0707 can be. So that's simple. Now moving to the next part. Now, 8 doors are to be packed in a wooden box, to send to a customer. The width of the box which we are packing, right, that is 82 millimeter. The thickness of each of the door is independent, right? Now, in this case, find the probability that the total thickness of 8 doors is greater than the width of the box. Okay, we are packing in a big box. That width is given. And 8 doors, the thickness are independent. The total thickness of 8 door will be greater than the width of the box. So for this case, we need to find the probability, right? Again, total thickness. Let's go. So here it's quite simple. The same concept we are doing, right? So the total thickness, let me name T. Of course, it is like normal distribution. So we will deal with mean and standard deviation. So how to find standard deviation and mean in this case? E of t, expected value of t, it's going to be, I know the mean for the total thickness, which is 10. Now that is just for one door. For 8 doors, it is going to be 8 times 10. Okay, so 80. And the variance of t. First, we will find variance, then we will find standard deviation as usual. It's 8 times v of x. 8 times, what is the v of x actually? 0.34. Do you remember this? For one door, we calculated the total thickness. Same. 0.34. And we will go with, wait, actually this is 0.34 is standard deviation. We need to go for v of x. We need to go variance. So where is variance? Yeah, here. Okay. So 8 times v of x. This is 8 times e of x. And this 8 times v of x. Now this is 0.1156. And when you multiply this, you will, okay, we won't use that one, but directly you can just solve. So this is actually sigma square. I need just sigma. So square root of 8 times 0.1156. You will get 0.961665. That is the sigma. Correct? Now, I got it. So the thickness in this case is normally distributed with 80, 0.961. Let me use everything for a better result. Okay. Now, what should I do? Probability that the total thickness of the 8 doors is greater than the width of the box. Greater than width of the box. What is the width of the box? 82. So probability of T should be greater than 82. Right? And yeah, the same thing. We're going to use normal CDF and solve this one. Let's go to the technical page here. Again, go for a probability distributions, normal CDF. And lower bound, it's actually x greater than I'm solving. X greater than 82. So I'm going to give the lower bound as 82. Wait a moment. Okay. So greater than the width of the box. So 82, at least you can just use 0.00001. So this is the exact 82 is not included. That is the lower bound. After 82 till infinity. So you can just put a lot of 9 over here. And in this particular case, mu is 80. And this also we found, which is actually 0.961665. That's it. Click OK. And we got 0.018. 0.775. This is the probability, right? Moving to the solution page. So I got the result and it is 0.018775. Right? That's simple. Now, moving to the next part, the description is quite different here. The company buy two machines, A and B, to make the wooden layers. An employee claims that the layers from machine B are thinner than the layers from machine A. In order to test this claim, a random sample is taken from each machine. And so first it's given 7 layers in the sample from machine A have a thickness in this millimeter. We can see this, right? So two machines A and B. The employee's claim is also there. We have to test the claim. And this is the first from machine A. 7 layer thickness is over here. Find the mean. Mean is very simple. Add everything and divide it by 7. So 6.23 plus 7.04 plus still 7.47 divided by 7. Very basic addition and division. And you will get it around 6.93 millimeters. That's the mean. Now, second question is find the mean. Then next, unbiased, find the unbiased estimate of the population variance. This formula is there in the booklet. So unbiased estimate of population variance, Sn minus 1 square equal to n by n minus 1 Sn square. Okay, what is this? I know n is 7, but what is S7? All these things. So for this, we have to create a list and go with the help of technology. Here we take. First, okay, I need to create a sheet. So take a sheet on only one list I have. So carefully give the values like it is 6.23, 7.04, 7.04, 7.31, 6.79, 6.91, 6.79, 7.47. All the 7 values had been listed and we created a sheet. So now you just keep the things over wherever you want the result. Let it be here. And I need to find the unbiased estimate of the population variance. We created a sheet. Now you have to go for menu, statistics, stat calculations, one variable statistics we are dealing with. So click on that. Number of list, only one list. Where your list is named as TX. Frequency list is 1. So there is no frequency list actually. So like that. And these are not needed, just you can do. So the result is there here. And we can see X bar, which is the mean. Sigma X, 48.5. Sigma X squared. This is actually Sn minus 1. And I need Sn minus 1 square. This is Sn minus 1. So square, it's quite simple. Equal this result, you need to square it. Okay. So if you want the calculator have to do the calculation. So just click equal. And which value to be squared, click on that. That is D column 5th row. And then put a square. So we got this. This is my Sn minus 1 square, which is called population variance. Right? So directly we can do with the help of calculator here. And that's it. Moving to the solution page. So the unbiased estimate of population variance is like 0.162929. So I can approximate it as 0.163 millimeters. So this is the unbiased population variance. Right now, Okay, so here, yeah, it's a squared, right? The unit might to be square. So millimeters times millimeters. And that's simple. Now, moving to the next part. The 8 layers in the sample from machine B have a mean thickness of 6.89 millimeter. So we already did for machine A, right? So 7 layers and mean thickness was given, which we found it actually. Mean for this is 6.93. We found the population variance also, which is 0.163. And thickness also was there, right? Yeah, so that's it. Now, for machine B, they directly give that. 8 layers it have. And the mean is actually, it is given 6.89. And SN value is given. SN is 0.31. Sorry, SN minus 1, not a squared one. SN minus 1 is 0.31. We have to perform a suitable test at the 5% significance level to test the employee's claim. Okay, so read that. Somehow, somewhere we cross the employee's claim. So what he claims is, since they are using 2 machines to make wooden layers, the employee claims that the layers from machine B is thinner than the layers from machine A. So basically, machine A the layers from machine A have the uh, thickness more. Okay, thickness is more in A than in B. That is what his claim. Now we need to make the hypothesis and test this one, right? And also they have mentioned, you may assume the thickness of the wooden layers from each machine are normally distributed with equal population variance. Fine. Okay, we have all this. Sn minus 1 the whole square is what we have, and in one case, but actually we can just go for 2 sample t-test. I have 2 different sample. So 2 sample t-test will be the best one. And I also we need to make the hypothesis for this. So let's make a hypothesis. What is the employee's claim? He claims thickness is different. So let it be thickness of A, mean thickness of from A and mean thickness from B is equal. That is the first one. Mean thickness is same hypothesis. Then alternative this is null hypothesis. Alternative hypothesis is mean thickness from A is greater than mean thickness from the layers of B. Mean thickness is greater than A. And what is employee's claim? Employee claim that machine A have the more thickness. That is what comes under this. So this is all done, right? Hypothesis is done. Now we need to apply 2 sample test. 2 sample t-test. Okay, for this, let's go and go with the calculator. And check the power. So here we go. Okay, take a new page. And we need to perform a test. Okay. Add a calculator. Stat calculation result test. And 2 sample t-test is what we're going to do. And data input method is on stats. We don't have the data. We directly have those values like x1, x bar is like first sample. What is the mean? Then here, what is the standard deviation? Like those values we need to give sx1. Let's go. So here I got 6.93. This is already calculated. For sample 1, it's all the things that we have solved. And one more thing, sx1 is 0.404, right? So this is from the calculation part, we can get this. So actually we should not use 0.16, that is Sn minus 1 square. We need to use Sn minus 1, not the squared one, which is 0.404. So be careful over here. And for first case, for machine A, we are just taking 7 layers. For machine B, they give everything like 0.6.89 is the mean. And SX2 also they give 0.31. Then 8 layers involved over there. And next one, the alternate hypothesis is greater than mu1. The first is greater than. And this pooled one, you can just ignore it. Go for it. So when you click enter, you got this complete sample test over here. Okay. And while you're testing, you will go with the p-value. P-value is 0.417646. And I need to test for at the 5% significant level. Correct. Now moving to the solution page. This is the necessary thing that is needed actually from this. This is a p-value. And p is equal to 0.418. 5% significance is 0.05. 5 by 100, right? So what should I do in this case? While testing, if you got p greater than the significant value, we should not reject the hypothesis, that is H naught, particularly here. So do not reject H naught. That is the test result. And also we can say there is insufficient evidence to support the employee's claim, which is clear from this test. And that's simple. The problem complete here, and it fetch you 18 marks. So do practice, and thank you so much for listening with us. Let's meet in the next video.